Building on our previous discussion of logic and truth, let's now dissect the very building blocks of thought. We're talking about ideas, terms, judgments, and propositions. Think of it as the grammar of the mind. It starts with truth itself, which we express through judgments. But how do we make these judgments explicit? Through propositions. And what are these made of? Terms. Meanwhile, judgments themselves are built from ideas. So we have this neat hierarchy. Truths become judgments, which become propositions made of terms, rooted in ideas. It's like going from a feeling truth to stating it clearly, judgment proposition. Let's zoom in on these foundational elements. An idea isn't just a picture in your head, it's an active act of the mind representing something specific. Every time you think about, say, a cat, that's an idea. Now, how do we talk about that idea? We use terms, words like cat. The crucial link is that whatever is true about the term cat should generally be true about the idea of a cat. However, there's a catch. A single word often captures only part of the full richness of an idea. Think of cat. It doesn't capture every unique trait of Schrödinger's famous feline. So sometimes, what's true for the whole idea might not neatly apply to the term used for it. This distinction also leads us to general terms, like cat, covering many cats, versus particular terms, like this specific tabby cat, referring to one unique instance. Now, let's get quantitative about these general terms. Imagine you're defining triangle. What makes it a triangle? 3 sides, 3 angles, interior angles sum to 180 degrees. That's its comprehension, the set of features that make it distinct. Its extension is all the triangles that exist or could exist. Here's the cool bit, the inverse relationship. The more specific and detailed your definition, high comprehension, the fewer things will actually fit that definition, small extension. Think equilateral triangle, very specific, comprehension, so only a few types exist, extension. But if you just say polygon, it's vague, low comprehension, but covers tons of shapes, large extension. You can't have infinite defining features for one thing. That'd mean no two things could share it. And you can't have a term covering everything. Unity is the minimum. It's a balancing act. Okay, moving up the chain. How do we form a judgment? By relating two ideas, like connecting Socrates and mortal with the concept of belonging. And how do we state this relationship out loud? With a proposition. Think of it as the verbal expression of that mental connection. Every judgment, and thus every proposition, boils down to 3 core components. First, the subject, the thing we're talking about, e.g. Socrates. Second, the predicate or attribute, what we're saying about the subject, e.g. is mortal. And third, the copula, the glue that holds them together, usually some form of the verb to be, e.g. It's the essential link that says the predicate applies to the subject. Let's linger on that copula, that little word is. What exactly does it do? Does it point to something out there in the world, or is it just about our mental state? The text argues strongly for the subjective view. When I say God is good, am I necessarily proving God exists subjectively? Not necessarily. I'm just stating that the quality goodness applies to the concept God in my judgment. The copula isn't a magic wand pulling things into existence. It's more like saying, this label fits this box. It establishes a relationship of applicability between the ideas in my mind, without making any claims about whether those ideas correspond to reality outside my thoughts. It's purely about the connection within the judgment itself. Now, how do we categorize these propositions? We can look at 2 dimensions. First, quality. Is it affirmative, saying something is true, all men are mortal? Or negative, saying something is false, no men are immortal? Second, quantity. Does it cover the entire scope of the subject, all men? Or just a part of it, some men? Every proposition has both a quality and a quantity. Combine these and you get 4 basic types famously labeled A, E, O by the medieval logicians. A is universal affirmative, all SRP. E is universal negative. I is particular affirmative, some SRP. O is particular negative, some S are not P, remembering them? There's even a little Latin ditty for that. It's handy because these categories are crucial when we get to analyzing arguments, especially syllogisms. What happens if we swap the subject and predicate in a proposition? Can we still keep it true? Sometimes yes, sometimes no. This is called conversion. Let's see the rules. Take a universal affirmative. Every man is an animal. If we flip it to every animal is a man, that's false. But some animals are men is true. So it converts to I. Why? Because initially, man is smaller than animal. After swapping, animal becomes the subject and must be restricted. For particular propositions like some men are mortal, swapping gives some mortals are men. Both are true because both men and mortals are restricted sets. Similarly, no animal is a rock converts perfectly to no rock is an animal because the exclusion relationship is mutual. But watch out, not all vices are rewarded O-type, cannot become not all rewards are vices. The meaning shifts subtly. Conversion isn't always straightforward. Alright, let's talk definitions. What's the goal? To clarify what something is. We do this using a proposition where the terms must be perfectly interchangeable. Swapping them shouldn't change the truth value or scope. Think every man is a two-handed mammal. This implies every two-handed mammal is a man if the definition is perfect. Now there's a historical debate. Port Royal logicians tried to split definitions into two kinds. Definitions of things reveal the real nature of objects, supposedly non-arbitrary, debatable, versus definitions of words reveal meanings, arbitrary, incontestable. But the author here pushes back hard. They argue this distinction is shaky. Whether you define geometry or the word geometry, you're still expressing an idea in a proposition. The goal is clarity, regardless of whether you're naming a concept or describing a physical object. So, forget the split. There's essentially one kind of definition, aiming to make the idea clear. So, how do we actually craft these definitions? One powerful way is definition by generation. Explain how something is made or constructed. Think math. A circle is the set of points equidistant from a center. This is great for abstract concepts we build mentally. Knowing how it's generated means we can recreate it perfectly. But what about concrete things like a tree? You can't really generate a tree conceptually in the same way. So we use definition by comprehension. We list its key characteristics. To define man, we might say mammal, vertebrate, bipedal. We usually pinpoint the genus proximum, the nearest broader category, like mammal, and add the differentia specifica, the unique feature, like bipedal. Finally, there's definition by extension, just listing all instances. Defining the planets by listing Mercury, Venus, Earth. But this is tricky, because you might miss one. Plus, the list gets long and unwieldy. Generation is best for abstracts, comprehension for concretes, and extension is often problematic. Whatever method we use, good definitions need to follow some basic rules. First, they must be short and clear. If it's convoluted or ambiguous, it fails its primary job, making the idea intelligible. Second, they need to be adequate. This means they must capture everything essential about the thing being defined, but nothing extraneous. Too much detail obscures, too little misses the point. It's a tightrope walk between being too vague and too specific. Now we shift gears to reasoning itself, starting with deduction. The star player here is the syllogism. Think of it as the classic deductive argument form. Its superpower is taking known truths and deriving a new truth from them. The structure is elegant. You start with a general rule, a major premise, link it to a specific case, using a middle term in a minor premise, and conclude the rule applies to that case. The classic example, all humans are mortal, general rule. Paul is a human, specific case. Therefore, Paul is mortal, new conclusion derived from the old ones. It's about moving from the general to the specific, ensuring the conclusion is guaranteed if the premises are true. Let's label the parts of this syllogism. The final statement, the one we're trying to prove, is the conclusion. Before we prove it, it's sometimes called the question. The supporting statements are the premises. The premise containing the main attribute, the major term, is the major premise. The other premise containing the specific subject, the minor term, is the minor premise. Now let's name the players. The major term T is the attribute in the conclusion, e.g. mortal. The minor term T is the subject Paul. And the middle term M is the crucial connector appearing in both premises, but not in the conclusion, e.g. human. It's the bridge linking mortal and Paul via their shared relation to human. How does this syllogism actually work? It's all about comparing extensions, which sets contain which others. Our goal is to show the conclusion, meaning T contains T. We do this in two steps using the middle term M. First, compare the major term, T, with the middle term. We find e.g. mortals contain men. Second, compare the minor term, T, with the middle term. We find e.g. men contain Paul. Now, put it together. If mortals contain men and men contain Paul, then logically, mortals must contain Paul. So, from the perspective of comprehension, the number of defining features, it flips. Since mortals is a larger, less specific category than Paul T must have more defining characteristics than mortal. Makes sense, right? Euler had a brilliant visual trick for understanding syllogisms using circles. Each circle represents a term's extension. Containment means one circle is inside another. Look at the first example. All men are mortal inside M. Paul is a man P inside H. Just by looking at the diagram you see P is inside M. Conclusion: Paul is mortal. Simple. Now the second example. No man is immortal. H and I don't overlap. Paul is a man P inside H. Again visually P is definitely outside I. Paul is not immortal. These diagrams make the logic almost self-evident by showing the spatial relationships. Let's look at two more examples using Euler's circles. First, a particular affirmative syllogism. Some A are B and B overlap. B is entirely inside C. The diagram shows the overlap between A and B must also fall within C. So some A are C visually confirmed. Second, a particular negative syllogism. Some A are not B, part of A is outside B. Every is entirely inside C. The diagram shows the part of A outside B must lie within C. Therefore some C are not B since some of C is outside B. Again, the visual layout confirms the conclusion. Euler's method really hammers home that syllogisms are about containment relationships. This visual approach highlights something profound. Syllogisms are purely formal. Their validity doesn't depend on the content of the propositions, only their structure. You could plug in nonsense and still have a valid syllogism. Look at these examples. Every courageous sentiment is commendable. Imprudence is a courageous sentiment. Therefore, imprudence is commendable. Valid structure, but the conclusion is false. Or my snuff box is on the moon. The moon is in my pocket, therefore my snuff box is in my pocket. Absurd premises, absurd conclusion, but structurally valid. Even every rat eats lard. Rat is one syllable, therefore a syllable eats lard. True premises, false conclusion. What governs this formal structure? It's the principle of identity. The conclusion essentially repeats information already present in the premises, just rearranged. It doesn't add new factual content, just extracts what was implicitly there. With 64 possible combinations of A, E, I, O propositions, most syllogisms are invalid. How do we avoid pitfalls? Hamilton boiled it down to 3 golden rules. First, stick to 3 terms. No sneaky wordplay changing meanings mid-argument that would secretly introduce a 4th term. Second, keep the major term universal and the minor term affirmative. Why? If the major term isn't universal, the comparison via the middle term breaks down. If the minor premise is negative, you can't properly apply the rule. Think, some artists are cubist. A table is an artist. Therefore, a table is cubist. Flawed. Third, match the conclusion carefully. The conclusion's quantity must match the minor premises. If minor is particular, conclusion must be. If universal, conclusion must be. The conclusion's quality must match the major premises. If major is negative, conclusion must be. If positive, conclusion must be. These rules ensure the logical flow is sound. Beyond the basic validity rules, syllogisms can vary in form depending on where that crucial middle term lands. Where does the middle term appear in the 2 premises? This determines the specific species or mood of the syllogism. There are 4 main patterns based on the middle term's placement. 1. Middle term is the predicate in both premises, e.g., all S are M. 2. Middle term is the predicate in the first premise and the subject in the second, e.g., all P are M, all S are M. 3. Middle term is the subject in the first premise and the predicate in the second, e.g., all M are P, all M are S. 4. Middle term is the subject in both premises, e.g., all M are P. These different arrangements give rise to different valid moods, like Barbara, A first figure, Celerant, A first figure, etc., which we saw in Euler's diagrams. The basic syllogism is just the starting point. Reasoning comes in many flavors. Hypothetical syllogisms start with an if-then statement. If it rains, the ground gets wet. It is raining, therefore the ground is wet. Disjunctive syllogisms offer alternatives, either it's a dog or a cat. It's not a dog, therefore it's a cat. Crucially, the alternatives must be exhaustive. Enthymemes are shortcuts where one premise is assumed. Epicurums bolster premises with proofs. Prosyllogisms chain arguments together. Sorites are like dominoes. A leads to B leads to C, C leads to D. Therefore, A leads to D. Think Montaigne's Fox reasoning. Noise implies movement. Movement implies not frozen. Not frozen implies liquid. Liquid gives way. Therefore, noise implies gives way. Dilemmas present choices with consequences for each. If you study, you pass. If you slack off, you fail. You either study or slack off. Therefore, you either pass or fail. All these variations, complex as they seem, can often be broken down into simpler syllogistic steps. So, what's the deal with the syllogism? Historically, it was king. The scholastics lived and breathed it. But thinkers like Bacon, Descartes, and Mill threw shade. They argued it's just formal manipulation, not teaching anything new. The conclusion is just hiding in the premises. It's tautology. Induction, finding general laws from specific observations, is the real deal because it discovers principles. Deduction just plays with them. Fair point? Well, maybe not entirely. Sure, the conclusion is contained, but it's often hidden. The syllogism forces us to bring together ideas we hadn't explicitly linked before. It makes the implicit explicit. Plus, look at mathematics. Complex proofs are massive chains of syllogisms. If we dismiss syllogism as useless, we have to throw out huge swathes of scientific and mathematical progress. It's a tool for organizing and extracting knowledge, even if it doesn't create it from scratch. Alright, let's switch tracks from deduction to its counterpart, induction. This is the engine of scientific discovery, moving from specific observations to general principles or laws. Think Newton observing apples fall and planets orbit, then inducing the law of universal gravitation. It's a two-step dance. First, you observe patterns and try to find a causal link between phenomena in specific cases. Second, you leap. You generalize that causal link to all similar cases, even ones you haven't observed yet. Pascal figuring out the barometer is a perfect example. He noticed mercury levels changed with air pressure in several tests. Step 1, finding the causal link. Then he boldly declared this relationship held universally. Step 2, extending the law. How do we actually hunt down these causes in step 1? John Stuart Mill gave us a toolkit. Method of concordance. If you see phenomenon B consistently right before phenomenon A happens in various situations, B is a strong candidate for the cause. Method of difference. This is powerful. If you remove suspected cause B and phenomenon A stops happening, assuming other factors are constant, then B is likely the cause. This avoids the trap of just seeing things happen together. Method of concomitant variation. If changing the suspected cause B causes phenomenon A to change in the same proportion, they're linked. Heat increases, expansion increases. Method of residues. If you know several causes and their effects, subtract those known effects from the total phenomenon. Whatever is left over must be due to some unknown cause. It's like accounting for unexplained variance. Okay, step 2 of induction is the big jump, generalizing from what we've seen to what we haven't. What justifies this leap? Aristotle tried to sneak induction into deduction, but his example only works if you've seen all the relevant cases. Impossible. So induction is fundamentally different. It crosses a gap. Reid and the Scots suggested it's just an innate belief in nature's consistency. We assume the future will resemble the past. But the author argues for something deeper, the principle of causality. If everything has a cause and identical causes produce identical effects, then the laws we discover in specific cases should hold universally for identical cases. But here's the kicker. Empiricists say reason comes from experience. If induction relies on causality, and causality is a principle of reason, aren't we stuck in a loop? Induction needs reason needs induction? The author concludes we need a necessary truth, like causality, grounded in the mind itself, not just shaky empirical habits, otherwise science crumbles. We've seen how to reason correctly, now let's explore how we can go wrong. Fallacies. Errors in thinking. Francis Bacon, ever the keen observer, called these phantoms or idols that distort our view of reality. He grouped them, idolatribus, errors baked into human nature like our tendency to seek patterns or sensory limitations. Idosus specus, personal biases, our own caves distorting our view. Idolaphori, problems with language, ambiguity, misuse. And idola theatri, getting trapped in philosophical dogmas, like actors believing their roles are reality. It's a useful historical snapshot, showing Bacon recognized subjective factors in error. But the categories are a bit fuzzy, and the list isn't exhaustive. Let's try a more structured approach. A better way to organize fallacies is to mirror the two main forms of reasoning we discussed, deduction and induction. Just as there are deductive and inductive arguments, there are corresponding ways to mess them up. So, we'll look at fallacies of deduction and fallacies of induction. This keeps things clearer and more systematic. First up, deductive fallacies. Ignoratio elenchi is basically missing the point. You argue about X, but prove Y, Z, or something irrelevant. Like arguing about whether to go to war by giving a lecture on the general immorality of all war. Petitio principii is the classic circular argument. You assume what you're trying to prove. Positivists defining the self purely from consciousness states might be doing this, assuming a self exists to begin with. Vicious circles are similar, proving A from B and B from A going nowhere. An ambiguity of terms is sneaky. If a key term changes meaning halfway through the argument, you've effectively introduced a fourth term, breaking the syllogism. The scheme example is perfect. Scheme as plot in the first premise, but plan in the second. Different ideas in valid argument. Now for inductive fallacies. The poster child is post hoc, ergo propter hoc, assuming causation just because one event followed another. Seeing a black cat and then falling, concluding the cat caused it. Classic superstition. Another trap is improper leap, jumping too quickly from contingent to necessary or relative to absolute. Curing one patient doesn't make someone a universally good doctor, or assuming a good doctor will cure any specific illness. And the big one, imperfect enumeration. This is just bad generalization. Testing water rising in a vacuum up to 10 meters and declaring, nature abhors a vacuum, ignores the fact that water pressure limits its rise beyond that height. You haven't checked all relevant cases. These are common pitfalls when moving from the specific to the general. And that wraps up our deep dive into the mechanics of thought and argumentation. We've journeyed from the raw materials of ideas and terms, through the structure of judgments and propositions, explored the art of definition, dissected the engine of deductive reasoning in the syllogism, examined the leap of faith in induction, and finally, identified the common traps of fallacious reasoning. Hopefully, this provides a clearer map of the landscape of logic.